Thank you for coming out tonight. I want to especially thank Tim and Shelley and everyone at Oregon Wildlife for hosting this event. This is just wonderful. I'm Marty Brown. I'm the marketing manager at Oregon State University Press, and we're very proud to be the publisher of Helen Bishop's most recent book, Living with Thunder, exploring the geologic past, present, and future of the Pacific Northwest. Ellen Bishop received her MS and PhD in geology from Oregon State University. She conducted postgraduate study at Scripps Institute of Oceanography in San Diego. A scientist and teacher, her remarkable career has included public education, classroom teaching, and journalism. She's an accomplished journalist and photographer. In previous years, she wrote a science column for The Oregonian and served as the science reporter for Vancouver, Washington's The Columbian. She's designed interpretive displays for museums and developed video productions for OPP's Oregon Field Guide and Oregon Story. She's worked as a photojournalist for several papers throughout the Northwest, and her landscape photos have been used and displayed by conservation organizations, including the Sierra Club, Oregon Natural Resources Council, and the Nature Conservancy, as well as illustrating interpretive exhibits, including the High Desert Museum, Newberry Volcanic National Monument, and the Condon Museum. Ellen has written several books in addition to Living with Thunder, including In Search of Ancient Oregon, which won an Oregon Book Award for nonfiction in 2004. She's pursued a diverse set of educational positions, ranging from traditional four-year universities to community colleges to experiential learning programs. She's given talks, hikes, and workshops on a range of topics to groups of students, naturalists, photographers, scientists, and the public. And if you have a chance, I highly recommend you join one of her walks. Ellen's public service has included many environmental councils and projects. She helped establish and serve on Grand Ronde Model Watershed Council. She has served on the Bureau of Land Management Advisory Council, John Day River, and on the Fish Trap Board of Directors. She presently works as the Education and Outreach Director for the Eastern Oregon Legacy Lands Fund and their Discovery Center in Joseph, Oregon, and she's going to talk to you tonight about recent efforts underway to save the Wakulla Lodge. Please join me in welcoming Ellen Morris Bishop.
Thank you very much, Marty, and thank you all for coming tonight. I'm just happy to see you all here. I hope you all support the Oregon Wildlife Heritage Foundation. They're dealing with current wildlife, but as you know, we keep losing species right now. We're in the middle of one of the 6 great extinction events in geologic history. And without your help, basically, we'll lose more. So these folks are doing a wonderful job in trying to preserve and hold on to what we have and build more habitat. And I'll talk a little bit about our efforts in that respect too. But what brings me here tonight is basically looking at sort of the geologic history and really how we're connected with the planet. Because I wrote this book, Living with Thunder, because the title comes from the fact that we live with the thunder of volcanoes all the time. And it also comes from the Klamath Indian story, actually observations about the eruption of Mount Mazama 7,710 years ago on probably a Tuesday afternoon. But their tale basically is an accurate documentation of that. And I think one of the things that you'll find in here, at least in the introduction, is the fact that we often don't look at the understandings of indigenous peoples who lived with the landscape for a very long time. And so I wanted to look at that, and I also wanted to look at sort of the process of scientific discovery, which is sort of all around us. We're always finding out new things. So that's sort of what's in this book. And basically, we'll start out by looking at the fact that our intimacy with stones basically runs a lot deeper than the landscape. It basically goes back in time, and we're literally composed of the Earth's history. So if we think about where we all come from, there's the biblical story of sort of dust to dust, But the reason that we have T-Rex in here, even though we never actually, as far as we know, had T-Rex here, the only dinosaur that we have in Oregon is a hapless hadrosaur that seems to have been faulted northward from California and ended up in southern Oregon. But if you think about where we come from, I want everyone to sort of reach up and touch a tooth. Okay. So that tooth has a lot of phosphorus in it. And that phosphorus molecule has been around for billions of years. And it's been in a lot of different places. I know, we go to a lot of places ourselves, and sometimes that's good and sometimes not so good. But the phosphorus in your tooth might actually once have been there. Okay. So we are really the recycled planet. And to understand the history of the planet is really to understand the history of ourselves. I think what I've sort of said here is our intimacy with stones runs deeper than landscape. For better or for worse, we are literally part of the planet, composed not only of dust, but of Earth stars and former life. Whatever we are made of has been worn, used, eaten, grown, erupted, pooped, upchucked, and recycled countless of times before our individual selves have used it. The oxygen molecules of the Permian air, the carbon held briefly in the long tropical leaves of Eocene forests, the iron that inhabited torrid basaltic lava, these are now all part of us. The phosphorus in our front tooth may have once built the tooth of a tyrannosaur or the tusk of a woolly mammoth. The oxygen that fuels our cells may be the same atom that once journeyed through the lungs of a triceratops. It might have been cycled into the atmosphere 2.4 billion years ago by blue-green algae in the first riotous oxygen orgy of photosynthesis. It might have been inhaled by Secretariat on the home stretch to winning the Triple Crown, or exhaled by the tallest of the redwoods. We are the stuff of the planet, and its history is literally in our blood and bones. So that, to me, is a very important tie with the planet. And that's something that I think is something to just remember, that we're really part of this world, not just right here, but of past life and ultimately future life. So when we look at geologic events in the Northwest, I brought my cat's toy here, so I'm ready just in case any cats wander in here tonight, so you know. So Crater Lake, known as Moe'ana to the Klamath peoples, was a place that erupted within the scope of human history. And like many things that indigenous peoples have observed, it took us a while to get around to listening to their stories and understanding that they have stories not of isotopes and how much yttrium and deuterium might possibly be in these rocks, but of stories that humans can understand. So the Klamath story of how this erupted is like this. The underworld chief, Wakulla, sought to marry the beautiful maiden Loha, the daughter of the Klamath chief. Rejected by the young woman, Wakulla returned to his dark kingdom and shook the mountain in rage, thundering loudly as he stormed through the underworld passages and hurling lightning bolts towards his would-be lover on the surface. The thunder caused the top of Moe'ana, Mount Mazama, to explode. Great fireballs shot out, accompanied by 5 great booms of thunder. Ultimately, Gamakia, the creator, battled with the evil Wakulla, who continued to bellow with thunderous roars 20 times until Gamakia forced him back underground and sealed the fuming entrance to the underworld with hot rocks, sulfur, and ash. Then Gamakia made rain to fill the remaining hole with water, transforming it into a beautiful and sacred place. The lake is now called Gwas, the most sacred place. The truncated mountain is now Tumsumshi. So when we look at the scientific story of Crater Lake. And when Charlie Blake and other scientists have gone to Crater Lake and looked at this, lo and behold, they find, I know it says here, 5 large explosions. They can find 5 pulses of ash that came out of Crater Lake in distinct pulses. And this basically describes a volcanic eruption really quite well. So when we look at Native American stories of eruptive landscapes, like the story of Mount St. Helens erupting, and basically the whole story of the development of Bridge of the Gods, where you have Mount Hood and Mount Adams throwing rocks at one another in order to make Mount St. Helens, the most beautiful of all peaks, decide that she would marry one of them, then it seems as though you have a geologic story here. And indeed, there's evidence that people are researching now that looks at the eruptive history of Adams and of Mount Hood or Wyeast, and basically says, yes, indeed, there's the beginning of creeping evidence that at about 900 years ago, there were small eruptions that actually would have been the start of that story of rocks coming out of the summit of both of those mountains. So my point is that we need to go back, if we are thinking about Northwest geology, and look at basically the people who've lived with thunder for a long time. The Clatsop nations have stories basically of the Great Shaking, and the idea of the earthquake that occurred January 26, 1700, magnitude 9 to 9.2, created tsunamis in Japan. These are stories that we can tell. The Clatsop Nation has stories of basically drowning villages and of the fact that you needed to tie your canoes every time you beached them because you never knew when a large, big wave was going to come and take things away. So this is Brian Atwater, who is one of the quintessential geologic storytellers. The thing that attracts me to geology in part is that it is a science of story. We know a lot of details that people in general might not think of as being something they can understand, with a lot of data, a lot of chemistry, a lot of physics. But Brian basically made this discovery by simply coming up with a date from, there's a layer of dead wood in here. He dated the dead wood using carbon-14 and came up with a date of somewhere between the year 1680 and 1720. Okay, so that's not really tying it right down to January 26, 1700, is it? At 9:02 p.m. So in order to actually get a better idea, we had to go to stories. And those stories were found by a colleague of Brian's in Japan, where the shoguns in coastal villages actually had to keep good records, and they had to write stories of basically granaries that were damaged by water, of villages that caught on fire or houses that caught on fire, because those men actually had to reimburse people. They were kind of the local insurance people as well. So they had to reimburse people for loss of granaries due to natural acts and boats that were destroyed. And so there's this wonderful record in Japan of the tsunami called the Orkan tsunami that came across the sea. But the point of pointing this out is not only that we are at risk for earthquakes, and I'm really heartened to see a lot of, like cross pieces in here, and know that, because every time I come to Portland, I, bring extra water, and the people that I'm staying with took me immediately when I showed up out into the backyard, and it shows you their earthquake kit, which has all their camping gear in it and extra water, and they have a fish pond, so they have a water filter so they can share the water with the fish. So we're all beginning to prepare for this, but we understand it not so much because Brian Atwater dated carbon-14, but because we listened to stories, because we were able to understand things through that. So let me share another story with you. The story of the Nimipu, the Nez Perce, of how their world came to be. And in fact, how they came to be. It's really kind of an interesting tale. And it's germane to us today. So this is a picture of Timnipi, called Heart of the Monster. And the story of the Heart of the Monster goes like this. Once, a coyote was down near Salilo Falls trying to improve passage for salmon. And his friend Fox came running up to him and said, "Coyote, you have to do something. There is a huge monster. It is eating everyone." And of course, coyote isn't really in Nez Perce, Nimipu, or Cayuse or Umatilla. It's not really a little gray animal. Coyote is more just the trickster spirit. So coyote, or Itziyaya, says, "Well, all right, okay, I guess I have to go do something." And very reluctantly picks up a couple of flints, his fire kit, and a couple of extra stones. Goes up the river, and indeed there's this huge monster Nez Perce never described how big this is. It's just huge. And it has no name, it's just known as monster. And it is indeed eating all of the people. Well, the people at that point were, the badgers and the deer and the elk and the bears, the muskrat. So coyote says, "Well, I guess I have to do something or I'm just going to be here alone, and that's no fun." So he gets the monster to inhale him. He goes into the monster's belly. It's kind of a Noah thing there for a little bit. Builds a fire under the monster's heart. So that's an interesting point. Builds a fire under the monster's heart. There's heat there in the monster's heart. Ultimately kills the monster. Everyone gets out of the monster's mouth. And the last one out is muskrat, and the monster's jaw is just closing as muskrat leaves, which is why muskrats have no fur on their tail. And he has to kick bear somewhere along the way, which is why bear has a stub nose. But ultimately, coyote decides that that this is the time when humans are going to show up. And so he cuts the monster, and this is kind of an interesting psychological tale. He cuts the monster into pieces, and he throws a bunch of pieces to the east and some to the west and some to the north and some to the south, and those pieces of the monster turn into all the other tribes. And he's done that, and he's kind of proud of himself, and Fox comes up to him and says, "Coyote, you forgot something." He said, "What? We've got people all over the place." "Yes, but you have no people here." "Oh." So Coyote dips his hands into this bloody heart of the monster and shakes his hands, and little drops of monster's blood fall off of them. And lo and behold, those drops of blood become the Nez Perce. So the Nez Perce envision themselves in a way as being, along with everybody else, the heart of this monstrous individual. But here's the rock that is the piece of the heart of the monster that's left, from which the Nez Perce people sprung. Now, I will confess that I wanted to find out exactly which lava flow or which dike this was part of. And so when I was up there to take the photograph, I don't have any beautiful photographs of Heart of the Monster because I decided I was going to take a small piece of the Heart of the Monster from not the rock, but alongside of the rock. So I picked up this little piece and immediately, see this stormy thing? There were like lightning bolts and rain, and I paid no attention to that, and I put the little rock in my pocket because I was going to get it analyzed, and forever this debate about, is this the Pomona flow or is this the Wakulla flow? What flow is this vent for? And so I got back to my hotel room, and a whole bunch of really weird things happened. And in the morning, I took the little piece of rock back, put it right back in exactly the same place that I'd gotten it from. And I took a whole bunch of really wonderful photographs of this. And after I had done that and driven away, I discovered at the next place I was going to take pictures that I hadn't put the CF card in my camera. So, Coyote is still at it. But here's the thing about Heart of the Monster. Yeah, I mean, and I've talked with the Nez Perce tribal people, both at Nispelum and at Blackway, and they all think this is really cool. So, when you erupt a big basalt flow, you have to have heat, right? Okay, so the Nez Perce really see themselves as coming from this chunk of landscape. And I'm pretty convinced that it's a Pomona flow dike. The Pomona flow erupted 12 million years ago. It's the longest known lava flow on the planet. It goes all the way from Kamiah, Idaho, sort of follows part of the Snake River, fills up a big chunk of the Columbia Basin, and then follows the river down and actually gets to the coast near Astoria and actually near Long Beach and up here at some place called Radar Ridge. So the Nez Perce, and this is looking off of Buckhorn Point into the canyon of the Imnaha, and Hell's Canyon is over here. And these are all Columbia River basalt flows. So the Nez Perce truly see themselves as being part of this landscape, as springing from the landscape, as being an intimate chunk of it. And this is a chunk, if you go up to Rowena, you can actually see the Pomona flow as one of the top flows here along the Columbia River Gorge. So it's an interesting lava flow. The Columbia River basalts are probably Oregon's sort of premier claim to fame, and the Nez Perce see themselves as part of the landscape. I thought I'd just talk a little bit about these basalts because they are one of the things that brought me to Oregon and one of the most important pieces of geology in the Northwest. So this is the Wallowa Mountains, and the Wallowa Mountains basically display many of the vents, many of the dikes that erupted Columbia River basalts. This is Mirror Lake and Eagle Cap, and you can see some red stripes that go up through these rocks. These are all vents, very narrow, very long vents through which basalt lava erupted. And this is what they look like if you're up close to them. So they're very narrow and 10 to 20 to up to 60 miles in length. So if you can imagine a Hawaiian eruption with fire fountains coming out of the ground and long cracks in the ground, these are Hawaiian eruptions sort of on steroids. If you go to Maxwell Lake in the Wallowas, you'll find this. It doesn't look very impressive. It's known as the Wakulla Ridge Flow Dike. So this area in here, which is about 60 feet wide, represents the vent through which the largest of all Columbia River basalt flows erupted. So the Columbia River basalts encompass an area that covers most of the Columbia Basin. They go all the way to the Oregon shore. They include much of the area around Steens Mountain. They go down into Nevada. They're flood basalts. They are a huge part of the landscape. They're basically what you see when you drive up the gorge. They're what you see when you're in Hell's Canyon. They're what you see if you go up to Walla Walla or to Richmond. They're basically what you see if you're off the coast of Oregon. The Wakulla Ridge flow basically is a flow, back up here, to point out that this is a single lava flow that kept coming out of the ground, and it erupted 9,000 cubic miles of basalt. 9,000 cubic miles of basalt. Erupted at about 10 cubic miles per day. And that's calculated basically from looking at the volume of basalt that you can calculate by looking at the flows wherever you see it, and also by the thermodynamics of looking at where at the rim of rock that this basalt heated, and it baked, and it made basically into a whole different kind of rock. And if you're a geochemist and geophysicist and you put those people together, they can look at the mineralogy and the amount of heat and length of time that it took to actually make, go back here to this rim that's standing up. And that basically calculates out to 9,000 cubic miles of basalt, 3 to 4 years of continuous eruptions of an average of 10 cubic miles of basalt per day. Not just here, but over a 60-mile length of this vent. If you want to see the Wakulla Ridge flow, you can go to Multnomah Falls. The top is not the Wakulla Ridge flow. Those are pillow lavas of a slightly later flow. But the second lava flow that occupies this area underneath that is the Wakulla Ridge flow, the biggest basalt flow of the Columbia Basin. Saddle Mountain on the Coast Range is composed mostly of the Wakulla Ridge flow. The pillow lavas at Cape Meares. So these are gobs of basalt, of the same basalt flow that originated in the Wakulla Mountains, flowed across the Columbia Basin, and ended up going into the Pacific. Many of the sea stacks and headlands on Oregon's coast, mostly north of Newport, are Columbia River basalts that come all the way from the vent fields in eastern Oregon, in the Wallowas, in Idaho, and flowed all the way to the Oregon coast. They're really, really huge basalt flows. So basically, sort of from the Nez Perce homeland to the Pacific Ocean, we're all connected by these basalts, and we're all connected by this geology. So let me share with you another bit of geologic storytelling, of how storytelling and how following Marcel Proust's mantra here, the greatest voyage of discovery is not seeking new landscapes, but having new eyes, of looking at something in a different way, of thinking about how things would have formed, is important to geology. And a lot of times, geology or science in general gets a bad rap because people who don't really understand science will say, well, 20 years ago you said that, the Columbia River basalts, or the rocks on the Oregon coast erupted right there, and now you're telling me they came all the way from eastern Oregon. So I don't believe science. It doesn't have the same story all the time. And no, we don't. We keep changing our story because we keep learning new things. This is a really good example of it. So how many of you have ever been to Smith Rock? Okay. Smith Rock when I was a graduate student, right after the glaciers melted back, I remember going out here on a geologic field trip, and the professor involved waving his arms and saying, well, you know, this is a little volcano. It erupted about 11 million years ago, and you know, there's tuff here, and then this is a basalt lava flow that came from somewhere else. We're not really sure where. And so Smith Rock was deemed to be a single volcano, and now we know that there's a very different story for Smith Rock, because somewhere, you know, I really don't like developers. I really, really don't. But every once in a while, it's good to have them around. And this is probably the only case where I know of where a developer actually did something beneficial for geology. There was a developer who was doing his thing a little bit to the east of Prineville. And it was told that, okay, so you have to provide water and streets and power and electricity. So he did this backwards. He put in the streets and the power and everything he needed to, and then he decided to drill the well. No water. Drilled another well. No water, at least not enough to support 15 trophy homes and swimming pools and all the other things that people want. So he went to the county court and he said, you know, you said I could do this development and I did everything I need to, but there's no water. So you have to help me solve this. They turned it over to Oregon Water Resources. They wanted nothing to do with this. So they turned it over to the Oregon Department of Geology and Mineral Industries, who just happened to have two geologists who hadn't really ever mapped in this area, but they just come out of the Owahis, where there are big, huge volcanoes, kind of like Yellowstone, that erupted about 15 to 14 million years ago. So these two gentlemen were used to looking at big explosive volcanoes that are very large, kind of like Crater Lake, only bigger. So the first thing they did was they went to Barnes Butte. And they said, okay, Barnes Butte actually used to have a mercury mine in it. It has high uranium in its rocks. Those were all hallmarks of really explosive eruptions and large calderas. And they took a bunch of other samples, and to make a long story short, they eventually mapped out something called the Crooked River Caldera, which is about Yellowstone size. It's about 30 miles by 20 miles, and it erupted all in one big poof 29.5 million years ago. I apologize for the blue mysterious writing. So when I was a graduate student, we were told that, okay, so here's Smith Rock over here, that's one little volcano. Powell Buttes, that's another little volcano. Gray Butte, that's another little volcano. Grizzly Butte, that's another little volcano. And it took basically a whole new view of things by people who had sort of seen this before to come into this area and look at this with a whole set of new eyes and say, oh, this isn't a bunch of little things. This is Powell Butte. Now we know that Powell Buttes, really uranium-rich water, very warm water in their wells. Prineville, or Barnes Butte in Prineville is part of this caldera system. And this is basically all one giant Yellowstone-sized caldera that erupted once, possibly twice. And now we are basically looking not only at this as one giant caldera, but also at the landscape that's behind it, because now we have mapped out about 6 of these huge calderas that include, for any of you who've ever gone to Madras to look at geodes and thunder eggs at Richardson Rock Ranch, that's part of this whole caldera system that was exploding somewhere on the order of between about 35 and 25 million years ago. One Yellowstone-sized volcano every couple million years. So we go back to when I was a graduate student, and one of the things that always puzzled people was, where did the Painted Hills come from? Where did all of this ash that makes up all of the soils in the Painted Hills come from? And it goes from about 35 to about 25 million years ago. And I was always told as a graduate student, that it came from the Cascades. That, big volcanoes in the Cascades. Well, then we took a little new technology and we went and dated this cap rock on the crooked, on top of Carroll Rim in the Painted Hills and discovered that this is 29.5 million years. And Smith Rock is 29.5 million years. So now people are fingerprinting every single ash layer in the Painted Hills, and in fact most of the John Day Basin, and discovering that most all of this came from not only the Crooked River caldera, but in this whole big explosive volcanic field. So again, it's a story that we can tell as a story. It becomes sort of part of our history, our understanding of the landscape, and it comes from the fact that science keeps moving ahead. Oops, that was the wrong way to go. There we go. Okay, so this is Bachelor Butte. Let me just talk about another new thing that we're learning in Oregon geology. This is South Sister. These are the rhyolites and the rocks that compose South Sister and the Cascades, which is kind of gradually moving a little bit closer to Portland here. And until about 3 years ago, the idea was that South Sister was a young volcano, but maybe built a few 100,000 years ago, or possibly longer than that, even though there's a whole series of very young volcanics on the side. And so a couple of USGS geologists mapped out how old South Sister is and discovered that all of South Sister, this entire volcano, is less than about 50 million years old. So it's actually one of the youngest volcanoes in the Cascades. No, I heard someone say, that's not much. Right? So, South Sister is an incredibly young volcano, 50,000 years old, way younger than most of even Mount St. Helens. So most of the cone that we see here was built in only 10,000 years or less. So this is 20,000 years. So it took about less than 10,000 years to build most of this volcano. Its most recent eruptions are 2,000 to 1,100 years ago. So someday we can probably expect to hear from South Sister again, which again puts our living with thunder and living with volcanoes into a kind of a new, scary domain. So things change, landscapes change, climates change, and I'm not going to talk a lot about climate change here. I'm only going to point out that a lot of what we of what we see in Oregon's geology provides us with an exquisite record of change in climate as well as change in landscape. So if we go to the Painted Hills and see the red part, we're looking at these are tropical soils. So when the huge volcanoes in Smith Rock and generally in Central Oregon were erupting, they were depositing ash into a tropical climate. Okay, we can find eucalyptus, palm, lots of warm weather things here and a whole different fauna. I'm sure that if the Oregon Wildlife Heritage Foundation was around then, they would be preserving what lived there then. But as time goes on, we still have ash deposited, but we get lighter and lighter colors and much, much more temperate conditions. And there's a whole bunch of geologic reasons for that. But the nice thing about geology is that it does really, really, really record climate, it records the history of the Earth, and it's all kind of something that's internalized in us, ultimately. So, if we go back far enough in the Northwest, he's never sure why he's sitting next to the rock all the time. It's kind of a puzzle to him, but he knows that it's something he has to do. So if we go all the way up to the northeast corner of Washington, we can see how far out of kilter some of our climates have become. This is known as the Selway Formation, and these rocks in here are glacial dropstones. They come from a time about 700 million years ago when the entire globe was encased in ice. So we're not going there anytime soon, but geology gives us this perspective about what can happen in terms of climate change, how different this globe can be, how often it can change, so that we have we can go all the way from, in the record of the Northwest, and the stories we can tell about that, a globe that's completely encased in ice, to one in which there is zero ice anywhere, where everything is tropical. And we're all connected. They're also puzzled about why they're sitting here as opposed to running after the Frisbee. So this is a story basically about being up by Mount Baker in 2010, I believe. And I noticed that it was it smelled like a forest fire. This is in July. And I asked one of the rangers that I found, so how come it smells like smoke? Because I really don't want to get caught up here in a forest fire. He said, no, there's no fires around here. So, and then he noticed that, yes, it did smell a little smoky, so he called the ranger station, and they said, oh, no fires. But they were concerned, so they called the forest headquarters, Mount Baker National Forest. And the Mount Baker National Forest headquarters called back and said, well, no, there really aren't any forest fires here. In fact, there are no forest fires in Washington, but there are forest fires in Siberia right now. And that's basically what was causing this amount of smoke, so that you can't really see Mount Shasta. Seattle basically had record ozone levels for 4 days based on forest fires not here, but in Siberia. So the story there is, again, we're really all connected. And we're connected through time, we're connected through climates, we're connected through geology, through global circulations. And I think if we keep this quote in mind, seeking new landscape, not seeking new landscapes, but having new eyes, we will all probably be in pretty good shape. Yeah, I don't know why this chair was sitting out in the middle of no place. But they decided it was useful for some reason. So the moral of this story is always be prepared for the unexpected. And again, the greatest voyage of discovery is not seeking new places, but finding a chair in them.